Dear students, now I am going to teach the topic PN junction diode. So it is a semiconductor diode which conducts in forward direction. It does not conduct in reverse direction. Okay. See, P-type semiconductor, N-type semiconductor chemically combine together to form the PN junction diode. Right. And there are two electrodes. One is anode and another one is cathode. Right. Two means di. Right. Di-electrode. Right. Hence the name is diode. Okay. And here the PN junction is there, right? So P-type region and N-type region, this is the PN junction, right? That's why it is the PN junction diode, okay? And so this is the P-type semiconductor. Here the majority carriers are holes. They are represented as a circle. And this is the N-type semiconductor. Here the majority carriers are electrons. They are represented as a dot, okay? And when you are combining P-type semiconductor and N-type semiconductor, here the holes from the P-type region which crosses the junction and accumulate near the junction, which becomes immobile, okay, and electrons from the N-type semiconductor which crosses the junction and accumulated near the junction, which also become immobile. So they will form the depletion region around the junction, okay. So here the depletion region is defined as the region around the junction from which the mobile charge carriers are depleted, okay. And the barrier potential is defined as it is the potential developed across the junction. For germanium diode, the barrier potential is 0.3 volt. For silicon diode, the barrier potential is 0.7 volt, okay. And see, this is the symbol of PN junction diode, right? So this is the anode terminal, this is the cathode terminal, okay. Next, let us see the operation of PN junction diode. So actually, what is mean by biasing? Biasing means applying external voltage to electronic device, right? So applying external voltage to any electronics device is known as biasing, right? Here we are applying the external voltage to diode, okay, PN junction diode. See, there are two types of biasing in PN junction diode, forward biasing and reverse biasing, right? In forward biasing, this is the anode terminal. Anode is connected with positive, cathode is connected with negative, okay? In reverse biasing, anode is connected with negative, cathode is connected with positive, okay? That's the difference, okay? See, you just see the forward bias, right? So anode is connected with positive terminal of the battery, cathode is connected with negative terminal of the battery. Is it not? Here, so in P-type semiconductor, the majority carriers are holes, right? So which are positive charges, right? So the positive will repel. Is it not? So it is pushed in this direction, right? And which crosses the junction, and so the holes are flowing in the forward direction, okay? And in this side, in N-type semiconductor, majority carriers are electrons. They are having the negative charge, so they are repelled by the negative supply, okay. So they are pushed in this into the P-type region, and so that will be rotating in this direction. Due to the movement of charge carriers, there is a flow of current, okay. So in forward direction, forward bias, it will conduct. And reverse bias, see, in reverse bias, so anode is connected with the negative terminal of the battery, cathode is connected with the positive terminal of the battery, okay. Here, so in P-type region, the majority carriers are holes. They are positive charge carrier, right? So positive, negative will attract, okay. So positive charge carriers, holes are attracted by the negative supply. Similarly, here, so in N-type region, the majority carriers are electrons. They are negative charge carriers which are attracted by the positive supply. So the width of the depletion region increases. So it does not conduct, okay. So during forward bias, diode will conduct. During reverse bias, it does not conduct. And here reverse breakdown occurs. During reverse bias, reverse breakdown may occur, which is due to two effects, avalanche effect and Zener effect, okay. So what is avalanche effect? Avalanche effect means breaking of covalent bond is due to collision of accelerated charge carriers with the adjacent atom, okay. You just consider one atom. right? So collision of accelerated charge carriers. So fast moving charge carriers incident or collide with the atom. So here most number of charge carriers are liberated. Okay, because of that there is a conduction. Okay, so that effect is known as avalanche effect. Okay, and Zinner effect, here the breaking of covalent bond is due to intense electric field. Intense means heavy electric field, right? So heavy reverse bias is applied means the Zinner breakdown occurs. Okay, so because of this avalanche breakdown and Zinner breakdown, so when supply reverse bias is more means what will happen? Breakdown occurs. After occurring the breakdown, current increases. Okay, so that is the concept in reverse bias. Okay, and you just see VA characteristics. Right here, it is the plot between the voltage and current. So forward bias characteristics plotted in the first quadrant, reverse bias characteristics plotted in the third quadrant. Okay. See, in x-axis here forward bias voltage is taken, y-axis forward bias current is taken. Right. So here forward bias current, which is measured in milliamps. Okay. And so if the forward voltage is increased, right? So initially there is small current, right? If you are increasing the forward voltage further, so after reaching the cut-in voltage, current increases sharply, right? So what is cut-in voltage? The forward voltage at which current increases sharply. That is known as cut-in voltage. So for germanium diode, it will be 0.3 volt. For silicon diode, it will be 0.7 volt. Okay, right? And you just see the reverse bias characteristics. Here in x-axis, reverse voltage is taken. In y-axis, reverse current is taken. Reverse current in microamps. Okay, and if you are increasing the reverse voltage, so initially very small amount of current which is in microamps, that is known as reverse saturation current. Okay, so very small amount of current which is due to the minority carriers, right? That is denoted by I naught. It is the reverse saturation current. So if you are increasing the reverse voltage further, breakdown occurs. So this breakdown is due to avalanche effect or Zinner effect. Okay, so after occurring the breakdown, so current increases sharply. So, but we should not operate the PN junction diode in this region, right? In breakdown region, we should not operate the device, right? So, if PN junction diode is operated in the breakdown region, it will be damaged, right? So, it should not operate in the reverse breakdown region, right? And let us see the parameters. So there are 4 parameters in PN junction VA characteristics. So they are forward static resistance, forward dynamic resistance, reverse static resistance, reverse dynamic resistance, right? So forward static resistance is denoted by RF. Okay, this is based on the Ohm's law. R is V equal to IR. From that R is equal to V by I. Is it not? So RF is equal to VF divided by IF, right? So forward static resistance RF is equal to forward current divided by forward voltage divided by forward current, voltage divided by current, right? And forward dynamic resistance, it is denoted by small rf. So it is the change in forward voltage divided by change in forward current. Okay, and reverse static resistance, it is denoted by capital RR. Okay, so which is equal to reverse voltage divided by reverse saturation current I naught. It is the ratio between reverse voltage to reverse saturation current, and reverse dynamic resistance is equal to change in reverse voltage to change in reverse current. Okay, next VA characteristic equation, right? So here diode current I is equal to I naught into e power V by eta Vt minus 1. Okay, so I is the diode current, I naught is the reverse saturation current, V is the applied voltage, eta is the emission coefficient, okay, and Vt is the voltage equivalent temperature. Okay, then the applications of PN junction diode, they are used in rectifiers, right? So rectifiers, it is converting AC to DC. Okay, so mainly it is used in rectifiers. Okay, then wave shaping circuits, clippers, clampers and all. Okay, wave shaping circuits, amplitude limiting oscillators, log amplifier, anti-log amplifier, right? So these are the applications of PN junction diode. Okay, thank you.